Radicals frequently occur in problem-solving situations in which the Pythagorean theorem is used. Let's take a look at this application problem. What is the length of a guy wire that reaches the top of a 24-foot pole to a point on the ground 6 feet away? Well, let's draw a representation of what's going on here. So we have a pole. We're going to make an assumption that the pole is perpendicular to the ground. It tells us that the pole is 24 feet tall and that we have a guy wire attached to the top of the pole that is 6 feet away from the pole. And the question is, what is the length of the guy wire? So essentially, in this right triangle, if we pull the application information away, we have two of the three sides in this right triangle that are known, and the two sides that we know are the legs. Using the Pythagorean theorem, which states the sum of the leg lengths squared, which will let each leg represent A and B, is equal to C squared, C being the hypotenuse. Replacing the values given in this problem, each leg will be squared and added together is equal to the hypotenuse squared. Simplifying on the left, we'll take care of exponents first. The square of 24 is 576. 6 squared is 36. Adding those together, we have the sum of 612 is equal to C squared. To solve for C, we'll take the square root of each side and only look for the positive result since we're dealing with lengths. If we want an exact answer, we need to break 612 down, and if we work with this number, 612 breaks down into the square root of 4 times the square root of 153. Square root of 4 is 2. 153 does not break down any further. It's not a perfect square. So for an exact answer, we would say 2 times the square root of 153 feet. Or if we need some practical application and to know an approximate value to this problem, we would enter our 612 and take the square root of it and report that approximately, if we round this to the nearest tenth, that we would say the guy wire would need to be 24.7 feet in length as an approximation to the solution for this problem.